This is the presentation for the final project of EEL 6825 pattern recognition. My project is about implementation of optical character recognition. First, let me briefly describe the basic knowledge of my project. Optical character recognition, it's short for OCR, is a common technology that converts different types of documents like scanned paper documents, PDF, images of printed text into machine-encoded data. OCR can be applied in many fields and has become one of the most common applications of automatic pattern recognition. With the help of OCR, people can quickly automatic data capture from pictures, scanned documents, which reduces the data entry costs and maintains the high accuracy of recognition. In this project, a simple optical character recognition of template matching is implemented and simulated. Now, let me introduce the main work of the project. Here are the 6 basic steps I need to complete to implement an OCR of template matching. Step 1 is to input image file. Step 2 is to process image file. Step 3 is extract the features of the input image. Step 4 is OCR processing. Step 5 is space control. Step 6 is output the TXT file. But before we start the basic steps of OCR, template model should be created. In this project, template with font Andio Mono is selected. Template includes upper and lower letters from A to Z, digital numbers from 0 to 9, and simple symbols. After template generation, main steps can be operated. In step 1 and 2, images input and images processing. For further extraction and recognition, input image and a template image should be converted from colorized version into black and white version. Here are the picture of the black and white version of template. After template generation, main steps can be operated. In step 3, single character should be extracted. 4 steps need to be processed. One is image boundary clip. Clip the extra boundary of the input image. The second step is row extraction. Extract each row of the text in the input image. Step 3 is column extraction. For each row of text, extract each column, which means single characters has been extracted. Step 4 is normalization. Each single character needs to be normalized into the same size for further recognition. Here are the example images of step 3. The top image is the black and white template, which has clipped the extra boundary. The second image is the result after row extraction. The third image is the result of column extraction. The final image is the example of symbol characters after normalization. Step 4 is the OCR processing. First, we need to store each template models into a matrix A, then we obtain the means of the extracted character and the template models. And we calculate two-dimension coloration matrix R of extracted character and each template model. Last job is to find the maximum element of R. The extracted character is identified into the corresponding template model. In step 5, space control, and step 6, output TXT file. First, we need to set the threshold to decide whether add the space between two characters. We set the threshold as minimum gap value divided by the maximum gap value of two adjacent template models. For the input image, we compute the gap between two neighbor extracted characters and compare it with the threshold. If the width value divided by the max width value of adjacent character is bigger than the threshold, we add a space between the two characters. After space control, we output the result at the txt file format. As for the evaluation part, our aim is to check the validation of the program. Several images as input with different length, size, and color. Here are some examples input images. After simulation with MATLAB, we get the txt output result. The result shows very high accuracy of recognition. The whole project achieves its aim at main work. Here is the conclusion. The goal of the project is to implement the OCR of template matching technology with the software MATLAB. After designing the 6 steps of the whole program, a good result was got from the simulation analysis. During this project, I have a deep understanding of optical character recognition and pattern recognition. Also, I practice my skill of usage of MATLAB and mathematical skills. My presentation is complete. Thank you. Now let me operate the whole program with MATLAB to you. Here are the whole documents in MATLAB of my project. Here is the main function of the project. Now let me run the main function. The models are created, and then we choose a picture of test. We choose the simple test first. Is the picture of my name is Lu Xiaoxiao, and then we get the result of a txt file. We save the file, and now we get the result. The result shows my name is Xiaoxiao Lu. It's 100% of correction. And then we choose another one to test. We choose the number test. We save the result. The number test is 100% correct. My phone number is 352-226-2665. And now let me check for large data. We run and we choose test 2. Test 2 is a paragraph with a lot of characters, and we get the result. Now we get the result. You can see from the result we completely convert the image into the computer encoded data, and it's completely correct. And now we choose to check the validation of input with color input, and we run the program and we choose test 3. Test 3 is a image with green color, and we save the result. And now we get the result of test 3. Test 3 is converted into computer encoded version completely, but here is a little mistake. It's here. In the picture, it should be a symbol, but the program mistakenly recognized the symbol into the letter Z. Here is the little mistake, but the whole program still maintains the high accuracy of recognition. And here are my display of the project. Thank you.